There's, you'll notice here, why did, this one came out so nice. What would have made this little fraction thing trickier?
If it was the higher exponent of the
yeah, what if the higher exponents, the bigger numbers on the bottom variable? So, just to do simple, what if I gave you f cubed over f to the 7th? What do? There's two ways you can do it. And actually, this is leading us to rule number 4 in a second. You could subtract them. 3 minus 7 saves f to the negative 4. You can do that. Okay, we generally do not like negative exponents. So therefore, when we don't like negative exponents, we prefer positive ones. You could do a Taylor saying. You could subtract them, and since the bigger power is on the bottom,
put 1 over f.
Yeah, you make it 1 over f to the 4th, and you leave it in the denominator of the fraction. And to that, you just discovered rule number 4. Rule number 4 tells you what you do with negative exponents. Okay? Negative exponents are it's kind of like the equations of lines. I can't get that to stick with people. I cannot get negative exponents to stick for love nor money. Don't know why. But basically rule number 4 says if you have a variable or a base to a negative power, notice f to the negative 4 here is the same thing as what? 1 over f to the 4th. If you see a negative power, a negative exponent, it means move it to the opposite side of the fraction. So if it's on the top of the fraction, you can drop it to the bottom and make it 1 over a to the m, make it become a positive power. It's kind of like an inverse, yes. So consequently, that's the actual rule. But what if I give you, what if the negative power is on the bottom?
So you move it up.
Then you can swap it. You can move it to the top and make it become a positive power. Okay. So if you see a negative power, all you have to remember about negative powers is that they move from the top and the bottom of a fraction. They just move it to the opposite location. That's all you have to remember. And you got negative powers down. Can't use that stick. Have issues with negative powers. So let's do like 50,000 of these. I should have done this on another screen. Pull out a little here. Suppose I said, quick, what is g to the negative 8 power? How can I rewrite it? 1 over g to the 8. Okay. What if I said take 2 to the negative 3 power? This is when I can't get the stick. What do you do when it's a base? It's a number.
2 minus negative 1.
Exact same thing you just did right there. It's 1 over 2 to the 3rd, which means it's really 1/8. You see a number with a negative exponent on it, it's a fraction. All right, so what's 5 to the negative 2 power? 1 over 5 squared, which would be 1 over 25. All you're doing, changing it to the bottom of a fraction. We're going to extend this here. Go this way. So I can throw about 1,500 more at you. So what's 3 to the negative 4? 1 over 3 to the 4th. And we all know what 3 to the 4th is. It is 81. So what if I give you 1 over 2 to the negative 2? I would, since it's on the bottom, I would bring it to the top. It would be a positive 2 when I bring it to the top. And so let's do the second. 4. Yeah. So negative powers, move them up and down. All they are. Raise your right hand. I solemnly swear to remember that a negative power simply means that the base should be moved to the opposite side of the fraction. I solemnly swear I will never forget this rule.
One question. What happens if you forget?
need to learn the coolest rule about dealing with exponents and fractions. That actually isn't a new rule. This is an extension of the same, but I need to show you the shortcut for how to deal with these babies. And unfortunately, I've yet to run across a textbook that teaches it this way.
This is rule number 5.
This is not rule number 5. This is more fraction action.
Fraction action.
Fraction.
Who writes the textbooks? Mostly college professors.
Yeah. You should write them tonight. No, you can write one so strong and all those.
I can write great examples. I don't want to write all the textbooks and explanations and all that stuff. Okay, I want you to realize here, okay, so this is several variables in one fraction, but it's like, this is not a new variable, this is a new rule, this is just the same, the fraction rule. Okay, ignore the rest of this, just look at the A's. You got A cubed. It's harder to look at lumpy other letters.
That ain't lumpy.
All right, so if you had A cubed over 8 to the 9th, what would you do? Okay, Josh says 8 to the 6th on the bottom. Why?
Because you take 3, I don't know.
You subtract the exponents, and where's the bigger power? On the bottom. Okay, so I'm going to tell you, the easiest way to do exponents in a fraction is to simply go, okay, where's the bigger one? Well, it's on the bottom. So I'm going to cancel out the one on the top, I'm going to subtract it down, which would leave me with A to the 6th. Okay, on the B's, you want to end up with positive powers. So do I want to move the B's to the top or the B's to the bottom? Because if I took the one on top, if I take that -4 and I move it to the bottom, what's it become? It just switches signs. It becomes +4. All you have to do when you move from top to bottom is switch the sign. So that is now B to the 6th. Okay. C's, oh no, they're both negative. Okay. You want to get it so it's positive power. So you would bring up the -5. If I bring up the -5, it'll become a +5 and leaves me with C to the what? C to the 3rd. And then lastly, the D's, which way do we want to move? Up. So you're going to take out the -2, make it a +2, and that's going to be D to the 10th. And that's all it takes to do exponents and fractions. When you move it from top to bottom, you change the sign. End of story. Way simpler. Books will go through some elaborate things for that. I never get that. It's that simple. Alrighty. Now, yes, rule number 5. This is one you should know, but people often forget. What do you get? What do you get? You didn't see that. What do you get when you take something to the 0 power?
1.
But why?
Because it's a rule. It's a rule.
Something in the math.
You can't argue with that.
Okay, would you all agree x to the 5th over x to the 5th? If I subtract 5 minus 5, I get x to 0, right? But what do you get when you divide anything by itself?
You get 1.
Any number divided by itself is 1, isn't it? So therefore, x to the 5th divided by x to the 5th should also equal 1. Therefore, anything to the 0 power is the same thing as equal to 1.
Amazing.
So you love to see 0 powers. You get to eliminate the whole thing and just make it become a 1. It's lovely. But I will put stuff like this on your test. What if I give you 2x to the 0, y to the, just y, that'll work, plus 4x squared y to the 0. Simplify that correctly.
Okay, so the second term is 1.
2y plus 1.
Because this x to the 0 becomes 1. Just that one little term. So now it's like I have 2 times 1 times y.
Plus 1.
So that's 2y. Okay. But this whole thing's to the 0 power? So that whole thing becomes 1, and you're left with 2y plus 1. So just be careful, be sure you're paying attention to exactly what's got the 0 power. Whether it's a single variable or it's the whole quantity. Kind of impact it.
Why? What would be wrong with that?
Alright.
Oh.
Okay, that's the 5 rules of the day. Now I get to throw problems at you.
Wait, what?
No, you haven't had problems yet.
Is there one more rule?
We are not getting the next rule for a couple days.
You know what?
Okay, I need to show you a shortcut. What you do is you have a fraction and it's got a negative power on the outside. Okay, there are 2 ways you can do it. Both are legal, but then one is shorter. Okay, I'm actually going to do it the long way the first time. You could, technically we should multiply the exponents together. So you could take and make that x to the negative 12 and y to the negative 8, but then you're stuck with negative powers. So you have to switch them so that y goes to the top and becomes positive, x goes to the bottom. That's perfectly legal. If it works better for your brain, do it that way. That's the long way in my opinion. And particularly if you have multiple things inside there. It is shorter if you see you've got a fraction with a negative power on it. It's going to make everything flip positions because it's negative. So just turn the whole fraction upside down and make the power positive. Then you don't have to mess with all the negatives. Now let's face it, we all have a tendency to mess up and lose negative signs. So that's going to be y to the 8th and x to the 12th. Got the same answer either way. But if you see a negative power on a fraction, it is generally easier and quicker to just turn the whole fraction upside down and make it a positive power. Okay, are you ready for this is your test.
Okay.
And yes, I still have to say 5 minutes of scientific notation to you as well. Oh, you whiny people. You spent it at home too long and got spoiled over Christmas.
I was at home. I was at my cousin's house. Same difference.
Alright, this one, you might as well start writing. You all are working this one. I'm just going to stand here and watch. How am I doing time-wise? I'm okay, all right.
You got 21, 8 and 22.
That is a 21. That is a to the 21st. Okay.
Wow.
Oh, boogers, I didn't copy the problem right. That was step 2 of the problem, boogers. Oh, well, we'll just do it that far.
Wait. Good deal.
All right. Simplify that baby down to the end. Final answer. Go.
Okay.
This one's on you all. No. You're working it.
Is that 8 to the 21st?
That is a to the 21st. So my question is, what should you do first? Multiply the top together, then worry about moving stuff up and down. So I want you all to do it, and then we'll fight about who's got the right answer.
Okay.
Pencils to work, or you'll be up here doing it.
I could do that. I could go out there and do it.
I'm talking about our do-nothings over here in the corner that want to just sit and listen.
I'll talk through it.
Well, you're not doing it. So when you multiply the tops together, you didn't change the bases, that became 2 to the what? 3 plus negative 2 is 2 to the first. A's, add the power of 21 and 8 is 29. 9, on the B's, 9 and 2 make 11, and C's negative 6 and negative 10 make negative 16. Okay, I'm copying the bottom down. I'm not changing anything. Okay, now you're doing the up-down thing. You want to keep your towers positive. So I have a 2 to the first and a 2 to the second. The smaller power's on top, so I'm going to bring it to the bottom and subtract, which will make 2 to the first. Yeah. Okay, the A's are going to go up, so negative 14 comes up and becomes plus 14, which is 43. Which way are the B's going?
Down.
So 11 would come down. We would subtract 11, which would make us have B to be 11th again. And then lastly, the C's, you got to think about that. Where would I keep them positive at?
At 16.
If I bring 16 down and make it plus 16, doesn't show up very good. I'll end up with C to the 6. How cool was that? I know I have 5 minutes. That's about all I need, or less. You should know this.